For those that don't know me, good evening. It's a Friday night. Thank you for staying with me. You know, it's Friday. You could be doing all kind of things, but instead you're going to be tucked away and doing some cool things with me. So good evening, AJ, Anand, Angus, Anton, Asim, Chantel, Colin, Darren, Esperance, Gareth, João, Juta, Coyote, Letitia, Martin, Najma, Noman, Prince, Raphael, Tom, Valentine, and Nick. If your names could be a little bit short, I'll be better for my breath. All right, good evening, everyone. It's good to see some faces, some familiar faces as well. Let me just get my pen back up. So it's been a while since I've done one of these sessions. It has been a minute or two since I've led one of them. But it's good to have such a cast of characters. Let's just get the screen on for a second. I've just come out of something, so my tabs all over the place. How are we all keeping on this nice and warm Friday evening? Do we have a nice Halloween, followed by a nice 5th of November, followed by whatever we've had since then? There we go. Yeah. Can you see my screen? Is that coming through okay? Where's the chat? All right, then. Yeah, cool. No, sure thing, Najma. So I know that I do talk a lot, and I will try to make it a little bit clearer as to what we go through. So it is a Friday evening, and you know, Friday evenings are well, in practice anyway, reserved for more slightly high level stuff. So we'll try to make it a bit more fun and engaging. Actually, one of my topics of interest lately has been talking about privacy and looking at the way that we can secure accounts and data and the way that we can transmit that over the internet securely. And I wanted to share some thoughts with you, some bits and pieces that might be of interest. All right, Juice. So good. You can see my screen. How about now? A cool PowerPoint slide that says preserving privacy that's coming through. You know what? Control tower and landing zones has been covered ad infinitum. It's almost become a meme at this point. I won't get around to it unless I really have to. But there is no, I don't have the material with me, I'm afraid. Otherwise, I would. You know what? One of the things that I'm a little bit uncertain to. I know Dan's talked about it so many times, and every time he does go through it, I feel like I need to learn this stuff better. So control tower and landing zones. It's a really hard thing to show and demonstrate because it's one of those cases of if I have an organization that's big enough that I need to make it's an account factory. That's what I'm sort of doing. I'm just making a predefined baseline of things that are going to be out of the box compliant. But it's hard to show you. But what I can show you is a little bit behind the scenes of data. Yeah, honestly, Colin, it's one of those things where I know it's against what they want you to know, but it's only going to be needed when it's needed. And at that point, if you need to implement a control tower or landing zone, it's a conversation that you would refer to the documentation. You have presets, and in fact, it's not impossible to just get one that works. I know that there are they changed it around now, but before on the SharePoint, I used to have a list of things for it's called a builder's library, I think they called it. That's got a weird name for this. So you can just get an out of the box solution to deploy a control tower or a building zone right for you. I think it's called the architecture center now, if I'm honest. Let me find that for you. Bob, on a second. Oh, where is it? Let me have a look. So control tower. If it's not here, it's going to be somewhere else. It's going to be in the solutions library. Solutions library. Can't type with a pen in my hand. Let me put that down. Solutions library AWS. If I can't find it, Colin, I'm sorry. I can't spend a day talking about something I'm not too sure of. Okay. That's a bit rubbish. But you know what isn't rubbish? Talking about something I have got in mind. So it's been sprung on me. It is DevOpsy. Okay, well, this is something that will be a little bit on that point. It's part of a series I've been talking about. If you have been with me a few weeks before, over the last couple of weeks, I have been talking about how you can secure your accounts, your data, your systems, and your software, and all of that is about keeping continuous communications between points A and B. For instance, if so that no one, example between me and you, would be able to intercept and actually access the information that I'm trying to share. But what if point A and point B want to ever have some of that information? So I want to go through some of the technologies that you and I we use almost every day. Some of the technologies that underlie the software, underlie the applications, underlie the cloud that we're going to use tomorrow and beyond, and consider exactly what information we're sharing now, perhaps. So even without the knowledge and of what it is, I'm trying to empower you with certain mechanisms by which you can then restrict this information if you do not want to share beyond yourself. Okay, so let's consider one of the most obvious features, perhaps, that we use every day, which is just your web browsing history. The things that you do when you're going from tab to tab, if you're a laptop or a desktop or a mobile device, odds are that by now your browser tends to keep track of pretty much everywhere you go on the World Wide Web. It's a good amount around you. In fact, I've spent so much time abroad now that my Google's just turned to Portuguese. It speaks another language, and I don't know how to fix it back. It's really annoying. That is to say, then, that if you go and click on your URL bar, this thing up top, if you're using Google or the like, and sometimes you can just browse through the URLs that you visited, it will actually go to your browser's history by some menu. You can probably see everything that you've done today, or yesterday, or last week, or perhaps the entirety of your entire history. Particularly if you're logging into Google or Microsoft or something else, that they do remember this web browsing. So, João Marquez, I'm painfully bad at pronouncing anything beyond names, though. I won't get into it. My Duolingo doesn't talk to me anymore because it doesn't recognize me. I'm saying the right things, but it doesn't want to hear me. But it's if you, I might ask you, João, can you fix my Google account, because I don't know how to turn it back. It is frustrating when I'm trying to make it back to English, but it doesn't want to listen. Then again, if you can invest in a nice VPN, if you can go to another part of the world, subscriptions are a little bit cheaper. Often Brazil's a bit cheap. I know Turkey's also a good place to get cheap subscriptions, but you didn't hear that from me. Okay, so the web browsing history. Okay, the thing that where we are able to get sort of a concern for when it comes to our privacy, but it is also a feature of sorts. It is helpful. We always look at this thinking as a blessing and a curse, but let's consider first the feature. So why is that helpful? Why is it helpful to have history? Well, one, I mean, I occasionally want to go back through my history. I want to find some web page or some video I know I was looking for early in the day or yesterday or some time ago because it helps me find information more quickly if I know it's there in the past. So in that sense, it's quite, it's solving a problem for me. And also, if you probably notice, your web browser's history is often filled for features like autocomplete when I'm starting to type in something and something then resolves to the rest of the word for me. So if I'm starting to type in a URL up here in the URL bar, and I'm looking for AWS, so and so, such and such. I just did it now, for example, with the solutions library. So it has recognized that it's a previous website I've gone to, and in the name of the page, the browsers might remember more quickly than it is what I'm looking for. So it's caching of sorts. Exactly. I can just go ahead, enter, and click, and voila, you're at that same web page thanks to a bit of memory in your browser that stores that past answer for you for the next time, which is a good thing. I mean, of course, it is a concern potentially for your privacy if that's something whereby you might not want someone else or something who has physical access to your device to start going and poking in through where you've done and where you've gone. But yeah, you just probably don't want other people to have access if you just so happen to go to a website or maybe a computer, maybe a lab environments, or just on a public computer or the like. So you can think of a few scenarios which this is, yes, a feature, but not some of the scenarios where this is actually not a desirable feature indeed, because it does invade your privacy in some sense, or at least it puts at risk for being invaded by someone else. So I want to talk about how we can perhaps think of sanitizing your history and remove it maybe altogether in ways that you may already know about. For instance, if like Colin's mentioned, this idea of the cache. If you're familiar with a web browser, it does have some option whereby you can keep some information behind and then optionally clear it away. So you can clear your browser history and also remove your cache altogether. And by doing this, then what it's going to do is going to clear your cache, by which I mean, forget all the places that you've been to, essentially put that out of the back of your mind. I don't see any potential risks in keeping it, just my opinion. Well, how about if I'm trying to get that data from point A to point B? See, there tends to be some features, yeah, that are more locked down, and it's perhaps a bit more heavy-handed solution if I say I can't ever go online because I might risk contamination, or I want to keep myself so sanitized that we indeed don't do the things I want to do. So it's not a usability trade-off that might suit many people if I can never get it out of the internet. But assuming though you do go and check up all the boxes and you say, yeah, delete everything, all of it gone, or so it seems. Well, okay, so to your suggestion of using private incognito, it might mean that it's private in some case, that negatively you're logged out of Google. It doesn't remember your session history, or you're logged out of Outlook, you're logged out of whatever you're logged into, some other account, until you can still want to use, even if you just cleared your history from now, something else altogether. So on that point then, okay, we'll consider what else might be a concern when it comes to your history and your privacy just beyond your own browser. In fact, it doesn't even matter if you sanitize your own web browsing history and delete the entirety of it, because as it turns out, typically it's not just you. There is any website you visit, any place you go to, any website itself is, on the server side, anything that's on the internet is also keeping track of that same information. You're just seeing one side of it, but that imprint is going to exist elsewhere, which is to say then that what we're seeing is servers. Servers typically contain a lot of logs. If you've covered yet CloudWatch, then you'll know it's useful not just for diagnostic purposes, but also in case anything does go wrong, you're able to then go back and see the logs. And the logs are helpful for a few things. Why would you say? Well, it's a loaded question. If our data is going to be used elsewhere, let's talk about so your log data. Tell me about this. Why would we want to have our logs in the first place? What's the point of CloudWatch in that purpose? Okay, to monitor our resources, to make note of how our usage is going. I like that one, to prevent fraud as well. To prevent fraud. So by somehow having an audit trail perhaps, or a paper trail of this. Yeah. So all in together, yeah. Caching cookies. Every time I clean my cookies, but I have a fish maybe for passwords. Annoyingly, yeah. So this is a larger problem perhaps, or usability trade-off. If you are also deleting all your past answers, that you're then sacrificing your own performance, your own desire to get stuff done. If you're then having to remember things by yourself and then turn to resetting passwords and so on. So it is a trade-off then, that if we store stuff on the browser, it could potentially get vulnerable. It could potentially be seen or leaked. And then I think possibly turning to a password manager would be a good thing there. Turning to a solution in software whose job it is to keep that outside for you by maybe a pass key, so that one key is going to store that hash value in a box, which then synchronizes across other devices. Yeah. Okay, well, so back to the logs then. Yeah, absolutely. To keep just an eye on these things. It's the snitch of the cloud. It's the keeping the who, the what, the when, and the why, which is ultimately a way to then know what happened underneath your nose. Because without this, we have no real visibility beyond just what's happening in real time right now. So that same data, the one that we use for looking at our stuff, could be used, yeah, for negatively, positively as well. So while you're also on the engineering side, on the sysops side, you might be able to see for diagnostic purposes how you're doing. You might be able to diagnose, some issues, and if it does go wrong, then, like you said, you can audit this out. You can reconstruct that history. You can then make out what happened step by step, log by log, figure it out who was doing what and when and why, and that might actually explain some problem. Yeah, the diagnostics come and go. Now, those diagnostics are usefully, they're helpful, I suppose, if you're trying to fix a problem, but it might also be helpful for auditing purposes. Now, I like your suggestion of preventing fraud there, because it's going to keep track exactly of who was accessing what and when. So it is our paper trail of what's going on. And you know what? It might even be used more generally for advertising purposes, or like the idea of cost, not the cost to you as a consumer, but to the person who's maybe interested in that log data as it's going over the internet, as it's being stored in your browser, maybe to then be analyzed in some way. Because if I can get my eyes on these things, then I know a little bit more about you too. Chantal, are you not seeing anything, Chantal? I'm seeing a big screen that says logs. Let me know if that's not coming through. Okay, it might be just your side. No, it's on CloudWatch, but this is the idea. This is where's this from anyway? Oh, this is just from Postman. So Postman is a way to monitor real-time APIs. So if you make data go from point A to point B, then you can see this by so-called a packet sniffer, whose job it is to kind of open up the packet and assemble what's inside as it's traveling through the network in plain text form. So another reason then to consider why you might want to encrypt your data, because with that same stuff that's going over the internet in clearspeak, so to speak, it's going to be used for analytics, for cookies, for advertising. Let's talk about that. Let's have a conversation. Well, more generally, the people who might be interested in this are going to try to mine you, try to extort some information out of you. Yeah, because that data might then help them figure out how you might monetize or how you might do something a bit more interesting with that same information. If an OU is using, I didn't know that about the organizational units, but perhaps, yeah, I suppose if I want that level of if I want that pane of glass to see things from a organization's point of view. It's been a while since I talked about it, but yeah, absolutely. CloudWatch monitor everything, stuff on cloud and off cloud as well too. So it's ultimately up to you how you treat this data, but it is ultimately your concern concretely when I say that information is going to be saved somewhere on a server in a bucket. So it's very similar to your own browsing history, but it's even more detailed and it looks a bit more like this. So that same information, which I were to look into. So for instance, this is representative. This is a piece so this is some configuration that captures what is a very common convention otherwise for information that servers log, that web servers are going to use, specifically when you visit them with a web browser. So if I highlight just a little bit there, you'll see that this log format, the so-called combined format, is indicating to me that it's quite common for a server when you visit some website that it will log, that is, remember things such as your remote address, otherwise known as your IP address. It might remember your, the time of day, the timestamp. So the time of the day at which you access that particular web page, it actually know exactly what you requested as well. So what is it that I was looking for? The name of the file, the folder, the URL structure, essentially, the thing that I'm specifically trying to get that I sought to download or just look at. And it also remember things like the referrer. That is the URL from which I came from, the actual full made URL. That's right, Colin. Yeah, S3. So it's going to be in a bucket where this data will, unbeknownst to you, be piling up into a log stream if it comes from the same source. And it even remembers the agent too, the user agent that you use, which is to say, like your browser, that kind of history habits. So perhaps this is all, willingly or not, every single time that you go to a browser, every website that you ever go to, if you do anything online, inside of that virtual envelope, the thing which you're pasting in with TCP/IP, the sequence packet, the destination, the source IP address, and the protocol, that information is going to be tucked inside as in there. Okay, so quite a bit more than just the request itself making up the server. But it includes, so it does include the likes of your IP address, this over here. So that's going to be on the outside of your envelope, your destination IP. So something like 1.1.2.3.456, whatever it is, ... And then just like we described already, it also includes some number of headers, some HTTP headers, as we discussed before, do then build up that a bit more. But in particular, it does include information that you might not want there being stored on some servers in perpetuity, since you have no real control of this anymore. If you, as your, on your day-to-day self, if you just go into another website outside of AWS, your information is now going to be headed out of your hands into some control, not necessarily deleting forever. That's right, Najma. So with HTTP, I'd go and have a look at how. So the hypertext transfer protocol is a way of sealing a virtual envelope in which data is going to be sent over the internet. You've got the information therein is going to be the source, destination IP address, the source and destination IP address, which is to say, I'm coming from here, I'm talking over there, and then perhaps some ports thereafter. So the likes of port 80, 443, and so on and so forth. So altogether, you have a better idea as to where to pass on that envelope if you're delivering a message. So how do you modify whether you want logs to arrive by stream or batch processing? I think, Raphael, that would be a question of what is your ingestion method? If you're trying to take this in by batch processing, then that's your answer. CloudWatch itself is accommodates for everything. I think it's often more usefully processed in batches, but if your data is simply just what you're doing right now, going from your homepage to your router to somewhere else, then that's one single alone request you're making. To be on the processing side is kind of your concern if you want to dig into this stuff. But absolutely, the CloudWatch is, I'm speaking more generally without CloudTrail itself. It's something that your information, the point is that your information is going to be stored on someone else's servers, Microsoft servers, Google servers, Cloudflare servers, all this stuff out there for perpetuity, unless, you have some requirement or law that requires that the server deletes it for you, which is on some schedule, or you have much more control over it. But that's not likely the case. So to consider, I'll go into a bit more detail into what the information is, at least how you can exert some control over it, how the information is actually being shared, because it looks a little bit like this. Is the recording on? I think so. Don't see why it wouldn't be. Yeah, I think so. Yeah, I think it's recording to the cloud. It's not a local recording. Okay, so let's go back and just peel back the first building block of HTTP headers. So if you keep coming back to this, perhaps because it's one that it really is worth looking into, and just only because in the world of systems nowadays, and to be an architect, you need to then be familiar with how systems and software interact. So that meeting point often does get defined at the web level, at the application level of the OSI model. So things on the web are so common nowadays that when you're using things like HTML and JavaScript and CSS and TypeScript and using web browsers more specifically and web servers, that's driving a lot of today's interactions with technology. It is how the world works, whether it's in more native applications or whether it's with more mobile apps or desktop websites or the like. So HTTP headers, recall, are just these key value pairs. The things like on the left and the right separated by colon that are inside of those virtual envelopes that indicate some kind of letting go of information, some piece of information that's being sent by the browser, then sent over to the receiver in this request and response pattern that's being sent back and forth. I will talk a little bit about VPNs and Tor this evening, Martin, if you bear with me, but just in a bit, how we can obfuscate some of that information. This stuff is the building blocks of HTTP headers more or less look like this. So if I, for instance, go to google.com and I search, as I often do, if I just put the word in cats, well, what's going under the, so what then happens is, in that web page, by me typing in Google cats, gives me maybe 10, 20, 30, I don't know how many million cats, but it's going to be some HTML underneath all of this that looks somewhat like this. So remember that HTML, which is this language I'm proposing, exists in Google search results, exists on a web page, is an anchor link for a tag. So there is this, there is this tag over here, and then this hyperlink reference over there. That's going to be the href attributes, which is the example of HTTPS example.com, for instance. And the word that the human sees, the one that you've actually typed in, is the cats after the, literally in our case, so just cats, opened and closed up. So I'm assuming, just for the sake of discussion today, that example.com is a website. It's full of cats. It's just a place we want to visit. So that's why it might be appearing as Google's search results when I type in the cats as a keyword. Let me build up a story nice, but because what happens is when you type this in, when you go into Google, you type in the word cats, when you go into a link or everything you do on your internet, that is literally what you're looking at in the search results in the story. Because then what gets returned then is that your browser not only goes and requests the web page, but your browser also includes a HTTP header. So the HTTP header is like this in that virtual envelope. That's specifically called the referrer in this case. That's the key in this case of a key value pair. Okay. So back to our headers, you're going to find this on the left, the referrer, and then the value of which is the URL that we from whence we came. So for instance, if I've just gone to google.com and I've searched for the cats, which that's my question, I've hit enter, and as like I've said before, the shortest proposal, the URL as short as it could be, might be a bit like this. So that's what you're seeing your URL bar if I went ahead and did the same thing. Let me just go and show you. Let's type in the word cats. Notice right there. So cats has come back as a result here. Of course, there's some other bits and pieces too, as I'll get into in just a moment. But this is the idea that those headers are being sent back because past the 10, 30 million, I don't know how many cats are all over the internet, all of which then has a link that when clicked, if I click through any of these links, is going to take me to some other search result. But the implication then of this HTTP header is that by default then, perhaps unbeknownst to you indeed, that when your browser is telling the whole story, from which web page did you just come from? Where did you come from? What other web page or what link did I come from? Now, why in the world? Why is that compelling? Why is that of interest? Why am I talking about this? Well, it's actually kind of useful for your website at which you end up on, because that's going to be helpful to their analytics. Okay, so they might come from knowing, okay, well, how many people are visiting my website? If you have a business, if you have a website online, you'll know that in the admin dashboard there is a way to see referrers, a way to know how many hops have how much time they spend on the website, how much energy they've what efforts does it take to get to you because of the SEO ranking. So all of that together forms some analytics, which to the website design is quite important to know. So how are people finding my website? How are they, what are they looking at? What click streams do they give off? Oh, I'm getting a lot of users from this place. I'm getting a lot of customers from google.com specifically when someone searches for cats, not dogs, but something else, but cats. So you can imagine in the world of commerce that just being very useful to know how people are finding you. It's very interesting to the world of website designers to know conversely, how will people who are apparently not finding you as well to stay on your webpage and get there? Okay, but this is also quite invasive as well, because now this website, whenever I'm trying to go to there, even though it's arguably none of their business, they know that when I went over to this website, let me just go to, for example, here, the first website I choose because I typed in the word cats, or these people right here. Let's keep it simple. Let's say cats. So if I go to cats and I go to the Wikipedia page, then now Wikipedia knows a little bit about me. It knows that I've come from Google. It knows that I've come from Bing, or that Mozilla is my Firefox, or any kind of other information, that it is in their analytics. It's in their best interest to know this about me. Because as you can imagine, there could be other links in my own website, or any number of other websites in the world, that just because you happen to visit them and you clicked a link and that was referred to by something else, now they're broadcasting your address on their own website, or any number of other websites in the world. And just because you happen to click them and click the link, you know, they now know where you've been referred to, so to speak. So it has long been a feature of HTTP then that that is enabled by default. The HTTP headers referrer, that wherever you end up on, it ends up leaking perhaps where you've been. So this is a bit of a fishy one. Okay, so yeah, the URL perhaps a bit like this. A partial address of the web page that makes up a request, the URL fragments of such and such, and the user information like this in key value pairs. Okay, origin, path, and query string may be included, depending on the referrer policy. And that's exactly my point, is that is enabled by default. That is already on, unless the website, or perhaps you as a user, have turned that off, or you moderate that in your response. Okay, and you're probably looking at this. I know, and for those keen-eyed people, when I did type in the word referrer with double R's, it's a mistake I made. It's not a typo that I've perhaps done, but I promise it's not actually my mistake. At least in English, the word referrer is not typically how you spell it. There is double R's, R-E-F-R, referrer. But the person who came up with this, the engineer, just, I guess, misspelled it. So there should be 4 R's in total, R-E-F-R-R-E-R. But fun fact, when the person who came up with the specification some years ago, the poor person who wrote that just made a mistake, and that's been since memorialized. Anyway, so that's what browsers do when, and that's what they've been expecting for years. This is nothing new, that they tell you, they leak information when you're going from one place to the next. It helps them, for analytics purposes, websites to know what links you've clicked on previously, where you've come from, and also how you got to their websites. However, there are other variants too. So referrer is one that's kind of common. But let's see other things as well. So ideally, I'd like to send over less information. If you look at this to the right, it'll be a little bit more comfortable than if example.com, the place I'm going to, the website for cats in this example, said, okay, I came from Google. That's not a big deal, but I'd rather I'd rather you not even know what I was looking for, if only because that seems unnecessary. I don't want to give off things voluntarily. It seems a bit invasive, perhaps. And who knows what kind of cat I'm looking for. Maybe I don't want you to know exactly what my preferences are. Maybe I don't want you to know if I prefer cats over dogs, or what other kind of breeds there might be in if I'm looking for cats. So it just feels a bit unnecessary to share over that information. But I dare say it would be better to not even tell example.com in our story that where I'm coming from, and essentially just get rid of this altogether, just wipe it from the screen. So how might a website go about by doing this? How might they moderate just how much output comes from your browsers at the service requests? Or maybe how might you, with special software, suppress some of that information to preserve the more of your privacy than what it is that you're doing online? Okay, so how do we preserve our privacy? How do we keep this under wraps? And for instance, this is another common tag that web pages, they can put in their own HTML code that does indicate to the browser that, yeah, you may be sending me your referring address, but only send the origin. Okay, so only tell me that you come from https google.com. And that's it. There's nothing after that. We're missing any more information in terms of query results, or, question mark query cats or the like. That doesn't exist. So if I just tell them the website I came from, the origin, not the specific page, not the specific query results, or my search results, that's maybe an improvement. Notice here in the world of HTML, this error has been fixed. There's 2 R's now, but anyway. Otherwise, this is a HTML solution to our problem. It's something that is also out there too, that the browser, assuming that it does respect HTML, is therefore going to send and refer HTTP headers, but with less information than the whole URL altogether, just the origin really. So just the domain name and itself, just the protocol. Okay. But what if I don't want even that to be sent over for the users? What if I want absolutely nothing? Yeah, it's a bit like if I say best food in Wrexham, then wherever I end up on, so whatever, let's try that then. So if I'm a Scouser, if I'm going to Wrexham, best foods in Wrexham. Now, me typing this into Google is going to pass over that origin request. So TripAdvisor knows that I've come from, let's see if I can actually capture this, inspect. So the 200 headers have gone like this. I don't know where I'm going to look for this. No, not in there. I'll try all. Referrer. Okay. Okay. All right. So hold on a second. TripAdvisor has no, that's not what I'm thinking of. It is a little bit janky the way that this stuff is posted in. Origin. Okay. Well, I know at least when I'm coming here that if I were to go to another website, let's go to Lisbon Tapas, then that is now aware this website, perhaps if I click through to their own website, which is not visible. Where is it? There. So now Lisbon Tapas knows that I've come through TripAdvisor, and they know that that's been a good, profitable venture for them to get number one spot on this. So it helps their analytics purposes to know this, if only because the origin request has been sent over along with my URL. So everyone does this. You know, you're going to tell them the information like your browser, your time of day, your user profile, and your device as well too. But if you don't want to send this over to your browser, if you don't want that to be over to your users, you can actually get rid of that content altogether. Now, Google does not do this. Google does not currently actually send over the origin, so it's part of the URL. But if you want to be even a better citizen and just not make it easy for browsers, more information than they need to, you can include this into your HTMLs, your page instead. And that tells your browser that not to send a refer at all, because the value of the meta tag in that case is none instead of origin. Okay, and there are other values as well too that you can go and read in the book that tell you a bit more about the range of opportunities when it comes to setting those settings. But these are perhaps one of the most common ones to look out for, to consider. There's an alternative as well too, that perhaps if you're a little bit more technical, if you want to get into the more control over side of the web server side, so not just the HTML on the server, but actually configure a so-called referrer policy. And that's going to go into the HTTP header that goes from the server to the browser. Okay, so Amazon to your client side. So in that case, the referrer policy can indicate that you only want the origin to be sent. For instance, this shorter form of the URL. Or you can actually indicate that no referrer could actually be sent in that particular case. Yeah, it's exactly how affiliate works. So if I go to affiliate marketing, actions I'll suggest is, I tried it for a while, it's too boring. Affiliate marketing. So you'll find a dropshipper, someone who's going to sell 10 types of t-shirts, and you'll get someone who talks about it and says how fantastic it is if you buy through their blog article. So 10 ways to get noticed, and then there'll be like links for me to go and click through. In fact, if I do give them the gratification, if I give them the satisfaction of dropshippers, this is how the internet now has come down to. Okay, so you'll need to set up your software, something that's going to capture those origin referrer headers to know that you've come from your blog as opposed to a legitimate Google search. That's broken for some reason. Okay. I know you can set them up with Google. There's Amazon sellers as well too. Yeah. And let me just pause there. I want to see, there was a question earlier that naturally you asked too. So to read about the hackings, what's going on there too. So in this case, like there are some concerns perhaps that you can delete these things from your web browser. You can delete, I will refer you to some URLs that you can try outside the context of this, like HTML remove or software that removes or hides, obfuscates HTTP origin referrer. So there are ways that can clip this away from you. Let's see if I can find you might have to set this up yourself. I mean, it's not clearly something that your web browser wants to install by itself, perhaps with a plugin or some third-party tool that does do this for you. Okay. But in that case, yeah. So there are some software that you can install in your Mac, your PC, your phone, that's going to typically try to scrub some of that information out for you, so that even when your HTTP requests go from your browser to servers, you can make sure that third-party software is going to remove a lot of that information for you automatically, because it's done in a way that you don't have to trust the website anymore. Okay, you don't have to trust that the information for you, because in a way, the Googles of the world will actually reduce the amount of information out for you. Okay, it's a perfectly valid concern, by the way. Like, it's perfectly plausible that then you'd have to trust someone else's work, some other person's protocol, someone else has some GitHub lab. But in general, what's working in your favor here is maybe open source software, where even if you're using software that other people can see you and the source code of, presumably it's less likely that it's doing something a bit more malicious. Capitalism always, or at least in principle, is going to help there too, whereby it's not often in the company's best interest to be violating those privacy of users, because presumably that would create some kind of backlash, which wouldn't be good for business. But beyond there is a lot of trust, I say, on your part and my part when it comes to installing that software. So, but it is still a risk. It's a risk from any angle. It's just a case of where do you want to trust or who. Well, the way my plan was to get through a lab and might be able to show you how this is scrubbed, at least on the AWS side. Let me come to how I could show you so there's a firewall around your architecture that could help you out too, because there's a lot of other information too that your browser might be sharing without realizing that it's doing, making it available. And that information is enough by which service can even fingerprint you, so to speak. That is to say, there is a technique that's called fingerprinting that in the context of the web means to take in an input of a whole bunch of characteristics about the request itself from the internet that's coming in, and seeing if you are that, if you can use those characteristics to create a profile of sorts of the user, to get this semblance of who you are and what you do, and to then better uniquely identify the user. Now, it doesn't uniquely mean that they then know you're Marco in the sea of everyone, but you will know, according to the system of fingerprinting, that it's the same user today as you'll see tomorrow, as you see the next day, because you can use that information with high probability to say, okay, well, we saw the exact same browser configuration again. We saw the same size, the same time of day, the same IP address. Odds are then that it is the same person and not just some twin on the internet who just happens to have precisely those settings. So it is to a degree of probability that they can match you and build a profile around you. So how is that done? Well, in the simplest mechanism, perhaps, is just to rely on something like your IP address. At some point, you are walking on the sand. You will leave behind fingerprints or footprints, like your source IP address. Because remember, every time you do something on the internet, those virtual envelopes, those headers we kept talking about, have your IP address. They have them on the outside, so to speak. So they have to express to where they're going, to the router in that case, HTTP datagram header, where it is supposed to go to. For that to work at all, there is going to be some information on the outside of the frame envelope to tell you where it's headed out to. So even at best, even if you do encrypt everything, if you think you're being smart, well, you still need someone else's work at some point. Okay, so on the outside, you're going to have the likes of the version. You're going to be giving away the source IP address, where you're going, the protocol, the time to live. In TCP settings, how many out of how many packets. If you need to retransmit, you need to send that back as a flag. Most of this, in fact, doesn't even constitute the body of the actual data. It is relatively small compared to how much information goes into the header itself. But altogether, then, is the information that you're leaking, you're exposing by just going online and doing something. Right then, so the IP address where you're going, the destination you're trying to send the information onto, your IP address in that case, the return address, the place that we're coming back to, that means you're literally telling the remote server what protocols you do, where you are in the world, and at least where your IP address is to some degree. Now, that IP address might not uniquely identify you. It might be because it turns out you live at home, you live in an apartment, you live in a coffee shop, in homes or corporate networks where there's many people. In a private IP address, that could, you share one public IP address with many people, and that's what we have by network address translation. You have one front-facing or one public IP address representing many people on the backside, but at least it does narrow the scope of whose IP address it could be, even if shared amongst a few people. So your browser then is going to send that virtual envelope over the internet as well. And another HTTP header that's typically sent over by the browsers is something called a user agent. And this is, again, another unique string of text that's uniquely identifying your browser and the version that you're using thereof, and the operating system your phone, your device is using as well. Okay, so for instance, if we look at this example, so a more standard format might look a little bit like this, and it is, deliberately overwhelming, but it's meant to capture just how much detail it might be leaked in the header's value. Okay, so but within this big string of text over here, it doesn't even fit onto one line, okay? That's how much it gives away. It's wrapping onto 3 lines together. That's some indication as to what browser I'm actually using. Am I using Chrome? Am I using something else? What operating system am I using? So be it Android, am I using something else? A phone, a laptop, a desktop, a tablet, something. So that is given away, willingly or not. Of course, a lot of people in the world presumably do have the same web browser. I think we can all hold a hand up to having maybe Google Chrome installed, so it's not that different. So that too, then, even with an IP address, might not be enough information to uniquely identify you, at least with high probability. Okay, so what else can browsers do? Okay, well, if the server has some ability to send some code over to your computer, if you can, for instance, send some HTML, some CSS, some JavaScript perhaps, and servers can actually integrate the browser and ask you certain questions. For instance, a server could figure out what's the resolution of your screen, what dimensions are you working on, how big, how small, should I render that information back to you? And that is practically useful if you think about it, to know, so the server knows how to render that information for you and your screen. Because before the days of mobile, like everything was just a rectangular box, but nowadays we have different devices, different sizes, different tablets. But that might not be enough, especially if you have the habit of full screening. If you always use the same resolution on your computer and your monitor, that might be another ingredient to which we can identify you. So the server might be able to figure out what fonts you have installed in your system. The server might know what time zone you're in, because that's also a value that's available in the context of the browser. Of course it does matter. Yeah, of course it does. Because these are things that collectively, with higher and more probability, are used to fingerprint you. The whole picture I'm painting is that these are things which, individually don't seem like a big deal. Okay, my screen resolution, where I'm coming from, my browser. But so even if I'm not logged in, even if I'm using various privacy enhancing software products, even if I try to remove some of those HTTP headers and the like, you're still leaking some other information. You're still giving away the extensions. You're still showing the server your plugins. Sometimes your browser might have installed them on. Okay. Well, yeah. So if you consider it to be PII, then it is. It's something that by probabilistically is going to identify you. So whether it's sensitive or not, it is personal. It is to say, to a higher and higher degree, if you're in the habit of using the same computer again and again and again, if you're habit of not changing a lot of those settings, that alone might be enough for a website to effectively track you. They might have this idea of this person who keeps coming back and keeps their browsing habits in check. So it might be innocuous. It could be completely innocent. It doesn't really matter for most people. It might just be used for statistical purposes. It might be helpful to get a sense of just how many users or customers you actually have, but it could also be used for more invasive purposes. And that is when that's when it is maybe PII. Okay, just like serving you targeted software, maybe based on your behavior of those websites, or just for tracking you. Yeah, just specifically, the catch is that even if you log into that server just once, if the server has been logging all your traffic based on fingerprint for days, for months, for years, at that point, retroactively with high probability, it can infer, oh, wait a minute, if the user on this day was Marco, and we think the same user was on these other previous days, now by transitivity, they know much more about your browsing history as well too. Okay, so rather unbeknownst to you, then perhaps even without an explicit header value being sent over for that brief moment to identify you, the collection of attributes, all these things that can be sent over, the characteristics that your browsers have and your browsing behaviors have as well, can be enough to uniquely identify you and have done so for quite a long time as well. Absolutely. So yeah, especially in the same history to every device, and that is also a thing with synchronizing across devices. We'll talk about a bit about VPNs in a second too, but short answer is that VPNs typically can't solve this. Okay, there's more to it than just hiding your IP address. It is a lot more, because if you still use your browser like usual, if you go from your user account as well, all of that same information is going to be leaked. It's just going to change one piece of it, just the IP address, but it's a bigger picture in total. And short answer then, Najmi, is perhaps it's because the hacker, or sorry, the website, not a hacker, but they somehow have got the same information through to you, because they're able to retroactively work out everything about your browsing habits, because they know with high probability, by transitivity of all the other things you've done, that information is being passed on. Even if, Frankie, your thing about the mobile thing, it's a fair question. Even if you did, I don't know. I'm hard pressed to imagine what more your phone is doing than your browser is, except I suppose that, you could argue that your phone tends to have additional features now too. You've got like GPS, you've got accelerometers, you've got gyroscopes perhaps. So there are other hardware features that your phone has. Theoretically, they could be interrogated by JavaScript code, typically on an opt-in basis. So you, the user, could deny access to those pieces of information. But overall, those characteristics, I suspect, could be used to identify you a bit more uniquely, perhaps because of those laptops, at least today, have less of that functionality. It's a really good point, Chantel. Yeah. I was talking to someone last week how they worked for in the Yorkshire Police, and he had to hack a phone in order to save a life. Except, long story short, he was able to piece information back together, and to come to the subject literally in a second, using cookies. In general, because of local storage, cookies by design are meant to be sent back and forth between a browser and a server. And then theoretically, yeah, that shouldn't be a concern if everything's encrypted. But we've talked to in the past already about how mistakes can be made. You might start on HTTP, you might be then redirected to HTTPS. So in general, storing things locally in local storage, at least to prevent things from accidentally leaking out over the browser, might not always be it. That being said, though, if you are storing things in local storage, they are literally available locally. So even if someone else, a sibling, a friend, someone who gains physical access to your machine, that device, let alone a hacker, could then see all that information, and not only also your cookies, but also your local storage too. So at that point, physical access, generally, all bets are off when it comes to your privacy. All right, okay. So let's talk about, beyond this user agent header, there is other headers, other things that your browser is often sending back and forth with the server. For day-to-day operations, it's ultimately a trade-off between usability and security and preserving your privacy. You could go overboard and go full Ted Kaczynski and have built your own computer, built your own network, built everything yourself. Watch Mr. Robot if that's of interest to you, to see how far extremes you could go to have to microwave your computer every few minutes, because there is a zero trust policy with what lives immediately outside your network interface card, because you don't know, because it is perfectly plausible that someone is, a smart person has thought of this already. But on the flip side, for usability sakes, I would probably recommend, get a password manager for sure. If this has not been the case already, do start yesterday getting a password manager. Check yourself from I think there was a session I gave a few weeks ago about how you can fall prey to credential stuffing attacks and rainbow attacks and rainbow dictionary attacks, all that stuff. If you don't have a password manager, it well may be that having your credentials leaked in one website could then be tried and targeted in other common ones as well too. The only way around this is to have different passwords, different user information. So then perhaps it's not too bad then if they do know who I am, because things I'm sending over is either encrypted and it's, favorably not going to be intelligible to anyone who looks beyond just the outside of the envelope. VPNs, they're said to be helpful, but they just mask one tiny bit. They don't help to actually keep you anonymous. They don't do anything, because it's like putting my hand in front of my face and saying, you don't know my face, but clearly you can still tell who I am. It's me, because I've always been here. I was there a second ago. You can quite clearly tell, if not by the rest of your silhouette and your habits and everything else about you, that is indeed still the same person, just that you're hiding one bit of your identity. So I guess there is no real way around that, because so long as you're on the public internet, you're publicly available, shall we say. And that is down to your cookies. I would say approach things with a healthy level of skepticism. Approach with a security first mindset of encrypt everything, keep password managers, use normal protocols if possible. And I don't want to be, you could go to lengths as to protect yourself, but chances are someone equally strong is going to be able to fight back and put downward pressure on that as well. So it is ultimately a trade-off in usability at the end of the day. Okay, let's talk about cookies. So it's probably one of those services that, we've talked about, one of those who probably come into, the course already, namely hearing about cookies, but there are different kinds of cookies too. Recall, okay, in general, a cookie is just a bit of information, a thing that a server puts on your computer. Cookie is just something that your computer's been stamped with in order to kind of help remember your identity, who you are. Okay, so in the absence of these fingerprints and the absence of specific headers and the like, we can just put a small random value with numbers and letters of the like on your computer, maybe even a bigger value if it has lots of users, and lots of uses to that value, in order to uniquely identify you. ID you. Well, you are willingly give it. So to the point of you then returning back to a website again and again and again, and expecting to have the same treatment of, oh, welcome back, or you've signed in again, or some, if you want your past habits to be stored somehow, you need to hand over something, basically a hand stamp, something that has tagged you and uniquely shows to the browser that I've been here before and remember me. So that is a cookie. Yeah. But what if using different browsers, different accounts on the same computer? Okay. So it doesn't necessarily know that I am Marco. It doesn't know that I'm me unless I log in at some point, in which case, okay, I realize, oh, wait a minute, Marco's cookies is value. I know who Marco is. But in general, there are different types of cookies and different settings for the cookies too that are worth knowing a little bit about. So we talked previously about how we can call, session cookies. So session cookies are used by servers on Elasticache to maintain state, so to speak. So they're there to maintain state. So think of stateful firewalls, stateless firewalls, this idea of remembering who you are, okay? Between the server and the browser, that's how they can keep that connection going. That is to say, without going too deep into it, okay, HTTP is stateless. So whereby so if I'm going on different browsers, different accounts, single computer, if I go to a web page and I haven't signed in, a browser icon might spin for a little bit and then it stops because the transaction between the browser and the server is complete. Or what if I want to remember who the server is? If I want to remember who the user is, therefore the second, the third, the fourth time, the fifth time, the browser is going to contact the server and present to you something, that little token. And that bean, that cookie, had better remind the server of who the browser is. And that is why we use the metaphor of the virtual hand stamp in that case, whereby the hand stamp is the browser's way of reminding the server, hey, remember me, you've seen me before. Don't make me log in again. I am Marco. I'm Marco because of the hand stamp, even though it's just relying on that virtual hand stamp, or really just some unique identifier to give over. So that's going to go into in the cookie header from browser to server. So then what a session cookie does is it's going to allow browsers. So a session cookie is going to allow a browser and a server to maintain some sort of state, this kind of state. Okay, so a little bit more concretely then, it's going to allow them to maintain things like shopping carts or previous things that you've done, previous interactions. So if I'm shopping on Amazon.com for the like, if I go to Amazon.com, and even though I've never come in through this particular way, it is with some high probability trying to remember. So I haven't been in through that way, but let me try and through this door. It might just be because I never logged in on this browser, but perhaps. Let me try within the browser. Oh, it's fine, I guess. But it will recognize a little bit more about me because in that case, there is if I press sign in, it's going to remember who I am. There we go. So just like before, it says, oh, I know who you are. I remember that cookie. In you go. So that kind of that preemptiveness to ready to hand some information over is there. I'm using EpicPen, Cat. It's free software, EpicPen. All right, so to talk about this then, Amazon's going to show you the same content again and again and again so that you don't lose your business accidentally by deleting it if you go over and simply change the page. So as an example, this is how they work. So when I first go over to a website that wants to plant a cookie on my computer, the response might look a little bit like this. Okay, so first of all, you see HTTP 200. I'm just answering to a question I saw about what kind of pen I'm using. It's called EpicPen. Should you want to architect, if you like to, I will need a pen. Sorry, this is called EpicPen, the software, the one that you see on the left with all the bells and whistles. And I'm using just some crappy. It's called XP Pen. I don't know. It was like the cheapest one I found on Amazon. I probably need a new one actually. But yeah. So that's the one I'm using on the left hand side. So not to worry. My point is with these things is when I go to a website that wants to put a cookie on my computer, the response is going to give me back a HTTP 200 response, which is actually good news. If you see that, probably you don't see this often because that recalls. Anyone know what is 200 give me back? What is a 200 response if you know? It is, yeah. It's a success. It's a good. It's an okay. So perhaps the best signal you can see is I've got an okay, and which just means okay. At least all is well. It's not something like a 404 error, which would be something like not found. 200 is simply okay. But the value, so the server is going to also respond with a key value pair down below of this HTTP header. Okay, it's going to say set cookie colon. So that's the key. And the value of which is session 1234 ABCD, just random numbers, but that's the same value that I previously used when I talked about cookies in the context. So the point here is that the name of the cookie is called a session cookie. And its value equals, in this case, 1, 2, 3, 4, ABCD. So if I visit the same website over and over again, you and you and you, you would all seemingly have different random values for those cookies. All of us would have completely unique values. So this number, this sequence of numbers, letters, and so on and so forth, would be completely different for each of us. I'm just simplifying it down to 8 characters, which isn't that long. That's 78 million in total, but you can imagine in the excess of trillions, in fact, which is to say that we would have different hand stamps that we're presenting every time. So absolutely, this is encased in the API. When I'm sending that over from left to right, the API is just the whole transaction, the whole handshake itself. But inside the handshake, or the meaning behind the purpose, is to send over some past answer to say, I've come here before. Do you remember who I am? That's a session cookie. It's a session cookie in the sense that within the API, it's supposed to expire when you close the browser, when you quit for the night, when you go home, when you reboot everything else. Now, with that said, there's a bit of an understatement because browsers nowadays will frequently preserve tabs from you. Notice when you turn off your computer, you come back the next day, it just goes back to where you left off. You might go to sleep and you might need to wake them up, but increasingly, those sessions, they live longer, don't they? I don't seem to really fully switch off ever. I don't have to fully wind down and back up again. So the idea is that it's not meant to last for over a year or forever. It actually has a much, much shorter lifespan by design. Okay? So that when your browser has received the cookie, when you click on some other page and buy some of the products on Amazon.com, your browser might say something like this, get / and then a cookie down beneath that too. So that exact same value from before. So recall from previously, that's just how your browser, that's the API that's going to send over to the server what hand stamp it is or what cookie value it is. But again, the idea is that the browser is closed. You turn it off, you come back for the night. Let me show you. Yeah, I'm going to close my browser. Let's close that all together. Oh, I didn't mean to do that. That was rubbish. I was using that. In fact, let me try and reset. There we go. So it is resaved. Notice that. Case in point, I was holding on to something previously, so hopefully that's not too gone. Okay, good. But the point being that you just shouldn't have the same session cookie again and again tomorrow. At least in this model, true for all websites, but according to cookies, we're still using them. That could be pretty good for your privacy because if your cookie is by design meant to be a session cookie and it expires pretty soon, a session cookie is a nice thing because it's useful for you and your experience in the website to go back and not have to authenticate yourself every day. That's pretty good then because it just means if you go back to the same website tomorrow, that cookie might not exist anymore. So a temporary session cookie might as well look like a brand new user as far as you can tell. So it can't correlate perhaps, by default that much information about you. But, and there are other cookies that you need to be, aware of that are being slightly bad for you and your privacy perhaps, the so-called tracking cookies, which are the exact same idea. Key value pairs are being sent from the server to the browser. They remember who you are, or at least that you're the same person, even if they don't know that you're exactly you and your identity, perhaps specifically, at least yet. But as the same name suggests, tracking cookies are really just designed to track you and me. Okay, so why would they want to track you? Well, again, it's probably for analytics, like we said. Maybe it's for debugging. Maybe they're thinking about, they want to know where your users were in case something breaks, or maybe just for advertising. Of course, advertising so that you get served different adverts so that from me, from you, so that they can then maximize their revenue by click streaming or serving up ads that you and I are more likely to individually click on because it's more relevant to us. Well, if you read that a bit carefully, when it says accept or deny, what you're really saying is accept or deny the session cookies. I don't think that that's asking you for these ones. So tracking cookies get more of a bad rep, okay, and rightfully so because, okay, so to give an example of how they're going to track your behavior, I'm thinking about time. I can keep going, but if you would like a break, just do let me know. I'm thinking about I'm just giving you a second or two to breathe. But to give an example of how the session cookies, how tracking cookies work, let's do that after a break. So just because it's been an hour, I don't want to keep you glued to your seats. Well, okay, we'll look at how that might be in a second. If you are interested in though, have a look at this then. Tracking versus session cookies. That's what we're trying to make sense of. All right. Let's go for 10 if you don't mind. That's usually the roundabout time.
Sorry to be easy to talk since we're having a break. Yeah, I find it really annoying. When you go on the sites, practically every single website you go on, whether it's your phone or your laptop, and you just want to get the information, it pops up this cookies thing or whatever.
Yeah.
Isn't there a way you can just blanket ban them? Because
go ahead, sir.
Yeah, I was just wondering if you could blanket ban them. Because sometimes I just want to read the information on the page, and it's like accept this personalization, like you're saying, advertising, cookies, this, that, and it can get quite annoying.
Well, there is a solution. The one I have got installed, and there's many of them. So let me just close the window. There's a helicopter that passes like every single day at this time of day, and it's super annoying. Sorry, Chancel. This is the solution. I would recommend going here and just getting this plugin. It's a plugin that's been put together that says, I don't care about cookies. And they will just, like you say, blanket ban them. It will just say no straight away.
Oh, thank God. Thank you. Thank you.
So due to EU regulations and increased awareness of online privacy, every website must get user permission, you willingly saying yes or no, or just out of annoyance, whatever, before installing those tracking cookies. So if you stuff the web anonymous, if you delete the cookies automatically every time you close a browser, websites will still ask for that permission again and again, because it will get very annoying. And I agree with you, Chantal. So this war of conflict of inconvenience just to, wave your hand at it and say, okay, whatever, swat the thing away, might then give them leads to then retroactively understand much more about you. I would have a look at this browser. This is the one I use. I know there's others out there too that just do this thing for you.
Thank you so much. Thank you.
There it is. So this is open source. You can tell the makers of the website. No. So this is whitelisted websites. If you do want to actually say yes, if you want to poke a hole in that group, then you can just whitelist them, so to speak. But that might be the answer. Cool. Let's go for that then, if you don't mind. Just give we'll talk about how they work in a few. Anyway, so yeah, if you Jute is absolutely right. If you do find yourself at odds with how to close and make no Control T for new tab, which is going to be as simple as Control T, and then I'll put up a new tab. Control Shift T will bring back a previously used one. So the timer in my case, the last one you just closed down. So a good way then to recall how whatever you just closed down accidentally or not. But right. Speaking of then, I was about to show you a little bit more about the cookies. So where we left off was this idea that these so-called tracking cookies were the more nefarious types. The session cookies, for helpful purposes, help us keep states. I mean, there are stateful ideas because HTTP itself is a stateless protocol. You're not going to know. You're not going to pass up the same information off again and again if by chance, because your browser's habits don't want to give that away. However, tracking cookies are there to help, to track. So I said these tracking cookies are maybe there for analytical purposes. These ones are the ones that do get a bad reputation, and rightfully so. Chantel asked about how we can say no to them or blankly, and there are plugins to help you achieve this, because I want to give you an idea. I want to show you how it's designed to keep track of your behavior over particular websites. Okay, so for instance, this is a set cookie header that's for Google more specifically. And that might be the kind of thing that gets sent over to your browser. And in fact, the user cookie by convention is called _GA for Google Analytics. Google Analytics, which they, of course, use for Google's analytical purposes. So value looks a little bit like this, equals mark GA123, so and so, such and such. But the point of the value is that this is generated on a website basis. Okay, it will be different than if that website is using Google Analytics. And Google Analytics, by the way, it's a tool that allows your website developers to let's have a look. Google Analytics. It'll be helping you more about what's clicking on what and who's going where, what browsers are they using. So if that's your concern, then you could also know as to why. Okay. It's changed a little bit since I was last there. Okay, no, I don't know, but the information inside is along the lines of, where is it now? That's annoying. Is it down below? So it will help me better measure where my users are coming from, where my people are sort of, you know what, I think it's maybe my browser that's hiding all that stuff from me. Google Analytics. So Google Analytics is going to send over that information for purposes that if not, I'm going to come back to it because I'm pretty sure I had some stuff on there. It's been a while. Oh, it's taking too long. Last chance. Are you going to work? No? Okay. No, it's not working nicely. Okay, well, so this is the kind of a cookie that would have been sent over anyway, which is to say that they then track, designers of the website can know what browsers are using, what operating systems have you got, the size, the dimensions of your thing, you know, you're just generally getting a sense of the demographic of their user base to know a bit more about who's coming in. Okay. So do I have any apps to download to protect the data? I will probably refer to you to a safer browser in case if concern of security or privacy, then I would say use Brave, use DuckDuckGo to previously to answer Najma's earlier question. That is one that's perhaps a bit more security focused, or one that is, I mean, there are third-party browsers that are very privacy concerned, and they try to disable a lot of these tracking behaviors for you. Brave is a good one. Perhaps the worst offender is Google, because you know they're the worst offenders for this. They do actually make the business off of monetizing people, the behaviors and mine. So you know, I'd probably put Google as the bottom on the list when it comes to privacy if you're concerned about that too. And there are others out there too, but I think the most popular is, of course, in the Microsoft system, you've got Edge, you've got Firefox too. They are more privacy conscious, I do believe, than Google, who is probably the worst offender. But in terms of apps, I would maybe say, I don't know. I don't know enough, but I know that there are websites now that claim to fix it for you. The likes of Incogni, which keep annoying me with their adverts, ironically enough, telling me to scrub the information off the internet at a service, at a charge. So they'll come to you and say, look, you get phone calls all the time from people that you don't want to talk to, and spam email and the like. We'll go on the internet, and on your behalf and your request, we'll fight that fight for you at the price. So I don't know how that works, but there you have it. So regardless of what browser we're using, it's more about the website itself, okay? Unlike the session cookies from earlier, which are meant to expire after a day, session cookies are meant to fade away after darkness, okay? So if you close your browser and the like, Google's analytical cookie here has a maximum age of this many seconds, which if you do the default maths, if you check it out, is about 2 years. Which is to say then that if you go to some website that is using Google Analytics by embedding bits of Google's JavaScript code into the website, well, whenever that Google code is being pulled from Google's website, Google then has an opportunity to plant that cookie on your computer. And then what you'll get is a unique ID depending on where you've been and if you visited there for the first time, based on that specific website, that's now embedding Google Analytics and injecting that into your session. Okay. And that cookie then is going to live in your computer according to the HTTPS header for as long as 2 years. That's very, very useful for Google. They love this because, well, it's perhaps the most useful for the websites. Is it perhaps less useful for you? It's more invasive for the likes of us. Now, Google, of course, has many other cookies that they use as well, but perhaps this is one that you should keep an eye out for, the one that starts with _GA. In the coming weeks and months, if you poke around some of your browser settings, you may very well see the likes of this. Now, that's a problem then, because do Amazon do the same thing? Very likely. You see, I don't know what they do corporate side, but you can maybe set this up as a software-based thing. So anything that can read headers, so any application layer protocol can do this. Your server is going to keep track of us, especially if you and I are in the habit of deleting our cookies, cleaning your history. You think you're being smart, you could be thinking you're doing the right thing by deleting your browsing history, which would be counterproductive for Google websites when they're trying to track you in this way, but a plus for you and a plus for our privacy behaving this way too. Yeah, but it turns out there are other ways too that they can track us, that websites can, including through the actual HTTP parameters or tracking parameters as well. So parameters are, again, the key value pairs that you'll often appear in the URL when you pass into your search results that often get sent out with a GET request typically. Your full URL is followed by the protocol, www, the place you're going to, /, and then these things. You've seen some of these before. If you recall when I was searching for cats just a second ago, in the URL was something like https google.com/search q = cats. And everything after that question mark in the URL is indeed a HTTP parameter. But it could be used for not so innocuous purposes anymore, maybe for like not just for searching for cats, but also to track you. And in fact, if you see ampersands, these things in URLs, that might mean that you have a second or a third or a fourth or way more parameters up there. And sometimes the purpose of those parameters is simply just to track you, just to track some person. I'm not kidding. Okay, so for instance, if I give you like a representative URL, which is a long one, and this is taken from example.com, it's got a path then of add engagement, question mark, and then I'll highlight over here, I think on the next slide. It's a bit more on it. Yeah, so click ID equals, and this extremely long-winded random string, okay? And there's a second HTTP parameter in this particular URL. So then campaign _ID equals 23. Okay, so then the campaign ID, certainly with such a small number, probably not meant to track you. That's meant to be sufficient enough input to the website to know what kind of adverts should be served to you, what campaign should be served up, what media campaign are they focusing with. But then this in yellow, this click ID, it's sort of a euphemism for a tracking cookie. Yeah, or a tracking parameter cookie. In that case, where it's actually going to keep track of you, specifically because different users are going to find that whatever link they click on has a slightly different value for click ID. So we'll all get a unique number for that too. So recall then that a tracking cookie is something that's sent via a HTTP header. This is what those headers look like. So the likes of those key value pairs of this and that and left and right. So it's harder for you and me to see it actually in the mess of things, unless we're more comfortable with the browsers, if we want to go around and start poking around some underlying settings, but they are there. And those are the tracking parameters are right in front of you, underneath your nose, at least, if you do click on that URL browser and take a look at that in its entirety. Now, wonderfully, at least for us end users who are concerned about privacy, who do want to go into browsers and even third-party software, there are more increasingly removing values on our behalf for us. So as soon as a browser manufacturer, as soon as a third-party software knows that, oh, wait a minute, this click ID serves no other good purpose than just to track our users, the browser will, or the software will simply just remove it for you. It will just drop that down. So before you do and actually give you no chance to click on anything. So it could just scrub or sanitize those kind of tracking parameters out for you. Now, to be fair, if the browser manufacturer doesn't necessarily know what the tracking parameter is called, or maybe if the website is constantly changing them around all the time, it's always changing the name, it's always trying to mix things up, it's probably not going to work so well. But at least it's an attempt, it's always trying to put some downwards pressure on this very commonplace technique of keeping track of you and me. So why is it going to track us? Well, this too can end up in one of those server logs that we saw in CloudWatch, because this would be instance for the web page that I'm requesting for, / add engagement campaign ID 23 ... That could very well be logged by the server. Remember, that's going to go into CloudWatch logs that I've been coming from somewhere, that I'm going somewhere, maybe stored in some database elsewhere, even in like something like Elasticache. And then that could then be used as information to know exactly, well, where have I come from? What pages have I clicked on previously? Because I've visited those links, and even what ads have I seen? And maybe that's a good thing commercially, because they now know what kind of ads I'm clicking on, what I'm interested in, and they can then securely, or rather more representatively serve more of that content up for me. The stuff I'm actually interested in, because based on past pattern behavior, I'm more likely to like this more. And that might be good for them as well, but probably not so good then if not annoying or invasive for you and me, that they know this, they can get into your mind. So something to keep an eye out then, perhaps something that might guide your decision in the days or years to come when it comes to picking your browsers. So you don't necessarily have to nowadays use the one that comes with your phones, comes the one with your laptop or desktop. You can, if you're more comfortable, install something like Brave or DuckDuckGo or Brave or the like. Just increasingly, we have more and more options, which is, I think, a good thing to do. Another way to think about these tracking cookies is to consider them generally third-party cookies. And they do this, Najma. So indeed, in the Google example we saw just now, that's how they're being used for advertising purposes, to personalize you. So if a website like example.com, and they're embedding the Google analytics we saw, the _GA, and therefore some kind of HTML tag and mentions google.com, well then example.com, which I'm trying to visit then, is the first party in that story, so to speak. And google.com is the third party in that story. What that means then is that your browser might get cookies from both example.com and google.com. But the most important ones, presumably, are the first party ones from example.com, because that's the website that I choose to go to, whose functionality I want to use. I want to go to them. The third party functionality, perhaps, like tracking my clicks and my internet behavior on that site by Google, that's third party. So third party versus first party cookies. So very commonly now, do browsers nowadays, they can offer us options by which we can disable those third party cookies. And that tends to be a good thing for privacy sakes. I would recommend looking into a plugin that can disable third party cookies. Plugins, find one that works for your browser, of course. They have one for everything nowadays, just literally from the actual web store that some person's put out there, fortunately enough, that will just say no for you on your basis. That will fetch that information before you in that HTML header, and then before serving it back to your computer, will just flat out get rid of or fail to return that envelope back. Okay, so that tends to be a good thing for privacy sakes, because now it means that I'm blocking those third-party cookies. It means that the ones from Google, the ones that are keeping track of me via cookies, but that doesn't necessarily mean then that the website isn't still using tracking parameters in some way. Now, you would only know about this by actually looking a bit more closely at the URLs you're clicking on that are embedded in the web page itself, and that's where now browsers and third-party software are additionally helping by giving us more and removing those third-party cookies, but even those parameters together. But to give a more concrete example of this, so to give you an example of third-party cookies and why companies like Google track your behavior on not just one website, but companies like Google and other advertisers to track your behavior on many places. So in this sense, third-party have increasingly become more powerful, more omniscient, for instance, than first-party websites, because the ones that you and I are actually visiting. Why? Because there's a lot of popular third parties out there, Google being one of the biggest ones out there for analytics. Well, if lots of different websites are using them, loads of people using google.com, maybe Amazon's using them, eBay's using them, Netflix using them, and so on, then that third party very quickly eats up data. It accumulates data and becomes way more powerful than any one of those individual parties alone. Why? Because that third party, in our case, Google, that's being embedded. Google is embedding cookies in Amazon and eBay and Netflix and every website you go to. And that third party, Google in our case, has kind of eyes into all those other websites. And it sends the same cookie to you on all those websites. Yeah, so Google might actually know that you're poking around Amazon's website. Google will know that you're into eBay and Netflix, and when Amazon might have no idea where you're checking out Google and the other ones too. They might have some idea that you're going to... Okay, so more concretely. Okay, so some more HTML here on screen, like we've seen before, but I've highlighted couple of salient characteristics in this example. So notice in this web page, I've not only given a body, so this contains so the body is the bulk of the page. I've also included the head. The head is, for the web page, inside of which is another thing called a tag, called title. And I'm doing this again just to once again demonstrate that there are more tags than we've seen in HTML in the language so far. And specifically then, so this I claim is meant to be representing my own website, my own website you can go to, the title of which would be Markiverse, like in the tab along with the bottom of the screen. Now, inside of the body of this page, just for simplicity, let's assume for now that there's one giant advert, one enormous advert in the front and center of my web page. There's no content for the sake of discussion. I'm just kind of getting rid of that just to make it easy. It's just one big advert, okay? So the entirety of my website looks like this. Now, where is that advert coming from? It's coming from, in our case, example.com, or our friends over at Google, specifically a file called ad.gif. And this particular URL, that's being used as the value of the source attributes of an image tag. So what I mean by this, so if you were to visit, so website A sending data to website B, this is an example when you come to my website, my story, you come to Markiverse, and what you're seeing is a giant advert right on the front of the page. Maybe a big GIF, it's moving about, a big graphic that's containing something coming from example.com. You see them all the time in newspapers and the like. Now, the implication of this is, well, supposing that every other website's doing this, eBay is also doing this too, okay? So for the sake of discussion, I've got the exact same HTML, except that this time, this advert lives at eBay. So the title of the page is now changed to eBay, everything else is the same. And moreover, just to make things more interesting, let's go and add Amazon into the mix as well. The exact same page. I've got three identical websites, just the name that's different. Okay. So the whole point of the story is that Marketverse, eBay, and Amazon are all using the same third party, the same example.com in the case of maybe someone like google.com, or in the real world, probably google.com. And they're all requesting from google.com the same GIF, the same advert. So that's the same file that's being accessed from the ad servers. But that, even that alone isn't a strict requirement. Okay, so the same website is being accessed by all three of these as being first party. So that's a first party. And what I'm referring to then as being a third party are these ones, okay? So I think the next slide will, yeah, right over this. So what I mean by that is then, suppose that you then open up your browser and so you come to my website, you come to marketverse.co.uk, your browser is going to download the HTML for my website. It's going to have a look at that and say, oh, there's an image tag in here. And that image tag wants to show this thing called an ad.gif from example.com. Okay. So your browser is automatically, just by nature of how browsers work, is going to send off a second HTTP request. And this time, this second HTTP request is requesting ad.gif from the host example.com. And just to tie today's stories together, it's going to probably include like a referrer, the HTTP header where it tells you where it's coming from. And that's useful for our purposes because that puts these requests into context, okay? Now, that server, the third party example.com, or Google, shall I say, our third party in our story, is probably going to respond. They're going to come back with an okay. So we said, yeah, okay, I'm going to go and get this thing from that server, and they'll return back a 200 response of, yep, that's okay from me. And also, let me give you back, and here's the adverts. So it's going to include not only the image, that whatever the image is, but also the HTTP header of itself, of its own. And it's going to be our old friend, this set cookie. For the sake of discussion, I'm going to propose that it's going to be injecting a cookie on my computer called ID1234 ABCD, because that's going to be my unique identifier for Google. And it's going to be the one I keep using for discussion's sake, 1234 ABCD. It would just be some large, long, a random hash value for this for each and every one of us. But my gosh, that is going to last an entire year this time. That's the number of seconds, by the way, in 365 days. For 1 year, that tracking cookie, that third-party cookie that's been injected into my request has been served back to me. That third-party cookie has been planted on my computer by example.com because I visited Marketverse first. I don't actually do this, by the way, but if you go to this website, there will be a secondary request going to google.com, that third-party request, which is going to then inject the unique identifier for this HTTP header of set cookie. And that's now going to stay with me for 1 year. Wow. So in that case, example.com is a third party. This is the first party. But here's a concern, okay? Because what's happened is when I visit ebay.com, when I go to another website with the same browser, my hand has been stamped by example.com already, hasn't it? So what happens is my browser now represents and shows that hand stamp to example.com again, sending the exact same ID and the same value that is the same hand stamp. And the host, just like before, is example.com. But this time the referrer happens to be eBay. I'd be coming from another place. So in other words, after I visited Marketverse, so I came to Marketverse first. I did that long journey to Google. Google injected I sound like a vaccine guy. They injected things into my brain. Now they put a 1 year cookie called abcd.1234. And then if I then subsequently go to another first party website, if I go to eBay, in the case of my story here, that is then going to follow around with me. Oh yeah. So every time you press accept, that is just by law, they mandate that there are tracking cookies that you are voluntarily saying, yes, inject my computer with that cooking value, so that the third party advertisers know that you've come from somewhere. They basically have a better idea who you are thanks to your hand stamp. So they have some unique value now on your computer. So because my hand has been stamped with this tracking cookie, this third party cookie from Google, my browser, when I visit eBay the next day, is going to present that exact same hand stamp again to example.com with this same referrer. So who's the third party when I'm getting ads from website A? Whoever's paying them to host those websites, follow the money, and there is someone who wants to sell something or whatever's of interest to them too. You just have, Google is this bigger, they're interested in lots of things. They will also want to know more about you in order to then accumulate better, more targeted media campaigns. So on the surface, they're not the ones advertising, but they are a broker for this stuff, which then they resell onwards. So the ones that I say no to, at least if we look a bit closer at the tracking policy, reject or accept third-party cookie message. It actually says something along the lines of essential ones. So, okay, let's look at this. So the Google Analytics one, let's have a look here. I'm working to implement this new cookie policy compliance as per the data protection rules. This was a few years ago, where now this is the pop-up of that has to come in place, okay? So this person is trying to build this up, to which the user has to be able to refuse or accept all the required cookies when they are using any website. In my client's website, I can see the following third-party cookies are getting stored. The Google Analytics one, yeah. Some of the stuff as well too, which I'm not too interested in. I've handled them, but all the cookies are domain Google. I have no control over them yet. I'm not able to understand how they're getting stored. Instead of blocking cookies are being set to, it's easier for you. Hold on, it's just a discussion. That's not really about this. Let's have a better look at the actual message itself. There was a nice graph I saw where the amount of people using Stack Overflow has just plummeted since ChatGPT came out because more and more people are asking computers about the problems. All right, so enable third-party cookies on Shopify for the best experience. Shopify uses cookies to provide a safer and better browser experience. How? Please enable third-party cookies or use a different web browser to get the best performance. All right, well, what does that really mean? I'm actually just going to turn to that cool place, the I don't care about cookies, because I do give a message about that. No, okay, maybe I'm wrong. Sorry, I thought there was more information on this. Oh, I can't actually find it when I need it because I've turned them off already, so they don't seem to appear on my side. The way that they would be, they are being high, yes. So if I was my website, if I said, yes, Google, I'm going to allow you to advertise on my website, I'm going to give you a little place to have that, Google will also piggyback that session and say, let me just inject a HTTP parameter so that I can better follow your person, whoever's landed on that first party website for an entire year. So the host is, in our case, example.com, but this time the referrer is a different place. I'm using these as examples. It could be just anywhere at all. But in other words, after I've come to my website, after a person has gone to Marketverse, the hand has been stamped with a tracking cookie, the third-party cookie from Google. When I visit then eBay the next day, you're going to be presenting that same number back and again with that referrer, which is, to say that the next time I go to my browser to visit Amazon.com, that same message, 1, 2, 3, 4, ABCD, is going to be sent from my browser to example.com to request the same advert, and this time to Amazon.com's website. The implication of this then is that by those 3 separate HTTP requests, example.com, google.com knows that I'm visiting Amazon.com. And before that, it knew that I went to ebay.com. Before that, it knew I went to Marketverse.com. And none of those places, so neither Marketverse or eBay or Amazon necessarily know that I'm visiting any of those other websites. So think about that. Google knows because the same information is being sent to them this way. And when I go to Amazon, I get the same tracking cookie, 1, 2, 3, 4, being passed back to them. So neither these websites know anything about the other ones. It's to say that they all work as first party independently. They don't know anything beyond that particular session. But the implication is that Google.com, the third party in this case, is more powerful. It is more all-seeing, simply because Amazon.com, or in the real world, Google.com, it's just so popular. It's so embedded in so many websites that Google and others, almost everything dare say about you and I and what we're doing on the web, just because those adverts are all over the place in this way. So we've seen a very, very simple example, but it's simple because cookies and HTTP really are just relatively simple. It's once you realize how they work and then you can use them not only just to solve compelling problems for us all and sessions and shopping carts and the like, but also can be used to monetize the internet and also be used historically to monetize the internet too. Or even worse, perhaps to track individual clicks and behavior. And all of those mechanisms with tracking in mind, what can we do to protect ourselves? So you might already know this feature. You've heard of private browsing. So I know Connor mentioned at the beginning, you've heard of incognito, you've heard of ways that you don't have to necessarily delete all your browser history and delete all your cookies, but you can, on occasion, and I do this too, just open up a special window, a special kind of option on your computer, which most browsers today support. It puts you into private mode or incognito mode with a hat on. And you can think of this as giving a different chunk of memory in the computer that it doesn't know anything about your past history. It doesn't have your past cookies. It doesn't remember your past usernames and your passwords. And you're sort of starting fresh so that everything you do in that window is brand new. The catch, though, is that everything you do in that window still works exactly the same as the web works, as we've been describing. So nothing actually is different. You still might be describing tracking parameters. You might still have tracking cookies. You still might have server logs, but you're doing that in a new, fresh face, so to speak. So that when you close that private window or you close that incognito tab, at least that information is being discarded from your computer. So that if tomorrow you do the exact same thing, if you then reopen up an incognito window again, then it's as if you're starting fresh all over again with that server. Except for the reality is that, as per our just discussion now, that fingerprinting is still a possibility because your IP addresses are still factored in as part of other information that for your browser might still be leaking over. So what you're not doing is contaminating so much, so to speak, but your general past browsing history, which specifically we've been using with your browser so far, is enough, I would say. So what you should realize is that browsing or private browsing or incognito mode is entirely client-side. Okay, this is all just on your computer alone. So particularly those logs that are happening when you go to somewhere that we mentioned elsewhere are still being stored by a server. They still live somewhere on. They might be storing perhaps a different tracking cookie or a different parameter for you because it doesn't necessarily recognize you from when you're in private mode or incognito mode. But it doesn't mean that your tracks are completely absent. You still have tracks from the internet. Rather, it's just really scrubbing them from your local computer and decreasing the probability that, but not eliminating the probability that a server still knows that it's you. Yeah. I mean, I would use this with care too. But that being said, if you go into a course of web development, if you already design your own websites, if you're already using private browsing and incognito, it can be helpful for dev purposes, because it's always a way of opening a brand new window that has, again, no recollection of past bugs or things that you've maybe had from past websites that you clicked on. So it's commonly now used more of a web development tool, and just to mimic the idea that you're starting fresh with some kind of website. Super cookies, though, although they do sound delicious, they are probably the worst kind of cookies, the most evil that we discussed today. Absolutely, Najma. So we saw session cookies. Session cookies are for maintaining state. Session cookies are going to be helpful for you to remember your shopping cart, your past inventory, your thing that next time you go to the website, oh, okay, we can just pick up where we left off. We saw tracking cookies that are for tracking you between third party and first party. Super cookies, though, are not so soupy. Yeah. Now, these are cookies that are typically going to be injected by a third party, like your company, like your ISP, into your HTTP requests, which is to say then that if you, from your web browser, if you go to some website, that traffic, of course, goes from my computer, through my phone, through some internet service provider, whether it's at home or wirelessly or in the real world, and whoever's providing me with that internet service, my BT or the Virgin Media or the like, they can actually see the contents of that envelope. There's nothing technically stopping them from opening it up a little bit. There's nothing stopping them from having a look in the envelope and adding one or more of those headers of their own. Yeah. So an internet service provider or a company can actually inject their own little idea into play. Okay. So, okay. Here's an example. So for mobile phone carriers, for example, if in the past they've been known to do this, I know O2 does this, whereby if you're just requesting a web page like example.com from your phone, and they might, halfway between you and that server, they might inject a cookie of their own. They might put one like this for the sake of discussion. I'm going to use the same name, the same number. So ID 1234 ABCD. But what's noteworthy here, though, is that value is not coming from your phone. It's not coming from your browser, because you can clear all your cookies. You can clear all your history. You can use incognito mode or private mode on your phone. You're not going to see any trace of this client side, because the bloody thing is being injected into your traffic by your internet service provider between you, point A, and the server, point B, in the public internet space. That is out of your control. So this is an example of a machine in the middle attack, if that makes sense to you, Najma, where your internet service provider is going to tell the story because they want to track you. Your ISP, so BT, Orange, whoever you're with, because of advertising relationships they might have with some other websites, they want to make sure that you can be tracked by that website, even if you've opted out or have been clearing proactively your very own cookies. So suffice it to say that these have been very controversial, and thankfully you and I do have some pretty good defenses against them. It's my browser again. Just never use HTTP without encryption. Okay, it's for no better reason. If your URLs are always HTTPS, S for secure, then something theoretically, then this kind of attack or this feature or this what was it called again? I can't remember. Hold on, I have it here. Let me give you a more concrete example. Of a cross-site forgery, reflected. Maybe it could be like, no, it's not these ones. Okay, this. So this is an example. Many sites on the internet rely on embedded adverts to make money. As the advertising industry has matured, a complex ecosystem of ad networks and marketplaces have developed to allow content providers to be matched with suitable advertisers. Unfortunately, as ad tech has grown more complex, hackers have recognized it too as a vector to deliver malware. Even big name websites and applications have carried out malvertising, it's a hard word to say, attacks in a few recent years. So some examples here. Okay, so if your site includes advertising, you are inviting a third party to add content into your web page. Let's see how you might be inadvertently exposing your users to malicious code. Okay, because your website, you are the first party in this case. If you rely on advertising from someone else, if you have a little section of your page dedicated to a third-party JavaScript code, internet adverts are usually delivered by a supply chain of multiple nested services. This allows ad impressions to be resold and targeted to specific demographics, and response rates to be measured in real time. So they're interested in knowing a bit more about your clickstream data, because behind the adverts, behind the ad publisher, behind the ad network is the actual content server, the place that where you're going to, which you have to by HTTP go to ask for that information, the GIF or the image. Every domain in the supply chain is a target for the hacker. If they can compromise servers hosting or routing advertising, they have a large pool of potential victims. They're even much more for an effective attack surface than hacking a single website. The point there is, if they can dig their nails into this part, and this is a popular website, then it's much more damaging than them targeting you directly, because you're falling into their honeypot. So a compromised server becomes a very effective way to spread malware because the attacker can target operating systems and browsers with known vulnerabilities. If only they knew more about you and what kind of thing you're using. So since only specifically vulnerable users are targeted, thanks to perhaps knowing what browser you're using, what outdated software you're on, any HTTP parameters which are being passed on, it can be very difficult for advertising networks to spot an infection because I can't see it. I'm up to date. I have no idea what you're talking about. Hackers can also use various tricks like delaying the that's nasty as well. So put it on a time bomb or only targeting every so-and-so user to defeat automated scans. Absolutely, yeah. This is a hack explaining lesson. So they do have things for. I'll send that over just for you. But yeah, so you can see other stuff they've got in this class. Malware can vary from annoying to malicious. Yeah, I'll talk about this in a second, okay? But a recent trend is the growth of ransomware. Have you heard of WannaCry? Or what was the one in Ukraine? The Nexus? Well, the WannaCry is probably the biggest example of this because it made you want to cry. And what happened was that was being embedded or injected into third-party JavaScript code because they got a way in. And every single website they went. So hospitals, schools, quite unfortunately, quite sadly, it was less than capable networks that were the most hard hit by this because they just don't have the SLA to come down and patch the networks. Like a hospital is more because a hospital is going to fix people. They're not going to come and update their IT that often, you know? Yeah, exactly. So often they'll try to go for the lowest hanging fruits. The most obvious examples where people will, make the honeypot even sweeter. It's going to look up your file. So ransomware, WannaCry was particularly nasty because it then sent over to other people in your email. So it went into your have you ever heard of the I love you virus? So 2001, there was in the Philippines, there was a graduate called so-and-so de Guzman. Yeah. And this was at the time the worst case of like a computer worm of its time because it was written in VSB, in Visual Basic Script. So Microsoft 2000 was a terrible, terrible piece of software. It was horrible. It did, for the first time, it was not giving you the option to show your file extensions. So previously in 96 and after this, after they make that mistake, they realized that they should actually show you what file extension you're on. And they did that. So by social engineering, an email would be sent out. This was going through the email as love letter for you.txt. And you think, oh, that's lovely. Let me go and download that, often clipped or compressed because it would often wrap onto the next line. You can't see the whole screen. So VBS, Visual Basic Script, is a type of interpreted file, which then would run on your file, run on your computer. It would send over to all of your email inbox. It would look up your files, encrypt them with SHA, and then sell on. So Onel de Guzman, who was he was arrested in the Philippines, and he actually had a good enough claim to say, I don't know if he did or didn't mean to do this, but it was a script that he was writing for a thesis because he was a computer scientist. It was rejected by his university, and somehow or other it got out. It wasn't supposed to go out, but at the time there was no prosecution, there was no body to punish this kind of behavior because there was literally no previous law to say anything to do with computer viruses. So there was no laws in the Philippines making malware at the time of creation not illegal. It did about $10 billion of damage. It wiped away 20% of computers online at the time. It was hugely, 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 hugely damaging. It made a big difference. And yeah, as well, like the Y2K bug, all this other stuff as well that amplified that voice. From that point onwards, it did change a lot to do with the laws, with how I say that now, but we've all got like third party with this now, because it's always like a good rule of thumb: don't trust your customers, don't trust third parties, don't trust anyone who's going to be inputting validation forms or putting stuff into your data. Go through any of this website and you'll see that any user submissions are often quite dangerous. Or you can just treat your people as, I don't know how to say it, but the internet is a sketchy place. And suffice to say that it's very controversial if your internet service provider too can track you. They can put in their stuff, a third-party tracking cookie, even if you've opted out for this, because it's their network. You buy into their service provision. And if they infect your users, they won't notice this and that. Okay, fine. I actually did a project on this once, which I recommend you go and do as well. And I talk about it as being a Raspberry Pi hole. Wait a second. So I bought myself a little Raspberry Pi, which you can do from like any kind of processor. And what I did then was I put something in between me and my router in order to sync all that traffic out. So yeah, for my reasons I give away, and I got the little compare man to get annoying just to prove the points. The whole point being that for privacy reasons, they can slow us down because every time I go to a website, there's a lot of other things that are being dispatched to other places. So all your JavaScript has to run, it has to load, it slows you down, and it can open up to vulnerabilities like this. So what did I say back there? So malvertising is a term for spreading malware through infected adverts. It works like this. You go to the website loads the infected ads. The infected ads silently, automatically load the malware into your device, and it's showing you all for those ads for the whatever, okay? So what I need then is something that stands between me and my router. So that's my device. I'm going to go and make a query. That Raspberry Pi, which is going to be some microprocessor like an Arduino or a PCB board, is going to understand that request and simply just drop the packet, because I'm going to some well-known, I'm going to a well-known, like a DNS blacklist. There are places where that is a reputable place to be finding adverts from. So drop those packets. And the rest of it, though, because they are separate headers, go on and get the real stuff from the internet and then wipe them up and then bring them back. So point being that worst case scenario, I think I got a picture of them somewhere. So here's an image of that, okay? So those are the kind of queries that I made in the space of an hour or so when I'm just browsing and habits. I can see where I'm going, what I'm seeing. I think if I turn it off and on again. Yeah, so Google Tag Manager, JavaScript agent, New Relic, those are known bad actors. Those are places that are blacklisted as places that often do serve adverts, okay? And essentially it goes from a website that looks empty. I can't find the example. Sorry. All right, like this. So I could be searching for a website, at least it won't load. That connection will just get dropped, so to speak. Sponsored content never ever works. But if I go to the exact same website, it will work, which is ironic because I'm going to the same place. So what would take like the Daily Mail website to look like this much clutter? Look how much JavaScript is running to then pull that third-party cookies in. Boots are in there. I use the Daily Mail as an example because there's just so much on there. Boots are just all over the place. Now watch. Turn it on. Reload. Look at that. It loads faster and there's less likelihood of that stuff. So worst case scenario is it doesn't work. Best case scenario is I just get like an empty space like this. So better. All right. The point is that we can definitely have things in the middle between me and my servers. But again, it's just a natural result of the underlying technology that we're being used today. But the answer is don't use HTTP. Use HTTPS. Encrypt your stuff simply always by using HTTPS is one solution to the problem, because at least in the UK, if some mobile phone providers get a lot of backlash for this too, because you can occasionally log into your phone from the provider's website. And with it go through a bunch of, you have to go through a lot of menus on BT's website to opt out of this feature that they will inject third parties into you. So I say this from experience. It is a nightmare. They will typically bury those options right down at the bottom of their settings page. So it's not even necessarily the easiest thing to find. All right. I probably would go on to talk about other bits and bobs too. If that's a problem for you, I'm going over time, but let me just recap very quickly, talk about these two, because increasingly there are alternatives to just DNS. DNS by itself is another problem. I don't think we talk about this enough, that if you go to DNS or really Route 53, that's also in the plain text. Think about it. When I go to get a website, okay, thankfully, like computers on the internet, they all have IP addresses. We know from the discussion Route 53 that those unique addresses we discussed, I don't have to remember them. But IP addresses, because servers typically have domain names, something like google.com, amazon.com, and others. But then when I type it in, there is a system deployed throughout the world on the internet whose purpose in life it is to translate domain names to IP addresses, so that on outside of those envelopes, indeed goes the IP address to the source and destination. But then you and I as humans, we don't need to know and remember exactly where those IP addresses are. You can think of this back in the day when you're in the habit of going and checking phone numbers to actual analog landline telephones. It was actually pretty hard to remember loads of people's numbers. So this might meant you've even went around with like an address book and you'd have people's numbers in. The equivalent of that is DNS, which just automates the whole process for us so that every website, every service, everything can get its own unique name, but it's translated automatically for us over DNS servers throughout the world to its corresponding IP address. That's a problem because DNS servers are typically in a few different places. One, you probably have one in your home, you have one probably in your company or on your network, and it's probably built into your home router, the device that you're using to connect to the internet. But also your ISP also tends to have a DNS server, and that DNS server that your ISP has probably knows way more IP addresses than you and your own home network does, because why would your own home network know about that many IP addresses in the world? But that being said, then, why would your ISP know about all the IP addresses in the world? Well, it's suffice to say then, for our purposes, there's a hierarchy. So that even if your home router doesn't know, even if your ISP doesn't know, then there's some other server in the world that can eventually give you the answer to the question like, what's Amazon's IP address, or what's BBC.com's IP address, and the like. And so for efficiency, once that answer has been figured out somewhere, then your ISP will probably try to remember or cache that answer, and then your home router and heck, your device or your browser might remember the same answer for efficiency, so we don't have to keep answering the same question. It turns out by convention, DNS uses port 53, hence Route 53, if you recall our discussion, of just using unique numbers to identify things like HTTP, port 80, 443, etc. But the catch is, though, that the traffic used for DNS is unencrypted, which means then that when your phone, when your laptop, when your desktop is asking your device or your ISP for someone else's, what's the IP address of Amazon.com? What's BBC.com? You're actually announcing to the world what website I want to visit. Why? Because when you're waiting for a response from the DNS server to actually tell you the corresponding IP address, that's not great. Moreover, your ISP then therefore knows all about that information, because every time you go and ask for a new website that you've never been to before, your home network probably doesn't know the IP address. So you have to ask your ISP again, and they then might ask someone else, and then so on and so forth. But now, crucially in our story, the ISP is going to know that I asked. So then your ISP, be it for your own home network or for your phone or something else, pretty much every single website knows where you've ever been to now, assuming they've been logging into this information, which they probably are, unless there's some legal requirements, which they probably don't abide to. So the case then is the DNS essentially requires that we ask those very questions. Where is the IP address here? And if the ISPs remember those answers, well, they can keep track of everywhere I've ever been to, at least at that high level. DNS then gives them back a translation from the domain name to the IP address. What it doesn't include is the actual specific page I'm looking at, but the specific URL, the folder or the file I'm looking for. So your ISP might know that I'm visiting somewhere on Amazon.com, of course, for its IP address, but it doesn't know what department or what it is I'm actually looking for. At some lower level, though, it does mean that there are alternatives to the standard DNS, which is called DNS over HTTPS, or DOH for short. And that means exactly this. Instead of me sending out DNS requests over unencrypted port 33 on the local DNS server, now they're sent potentially, if you enable this, over HTTPS. So what that means is that they're going to be sent over the HTTP protocol, which we've talked endlessly about in those kind of envelopes, but securely using TLS, Transport Layer Security, which is the encryption protocol that makes sure that no one else can even see what's going on inside the envelope, including your ISP. Now, someone is still going to know what domain I'm looking for, because after all, to whom am I sending this request? But maybe I'm sending it to Google, maybe I'm sending it to some third party, but I'm sending it to someone. But at least go to thinking that if it's not your ISP who really doesn't know that information, that's one way to think about it. There are alternatives to this. Maybe just round off. There's one last piece of software I was going to talk about, popular for some time now. It's called Tor, or the Onion router. So that's a piece of software that you can install on your Mac, on your phone, on your PC, or your device. And this uses encryption to solve all the problems I've been talking about thus far, to give you a high probability then that you're not, well, of your privacy. So Tor works. And here's a picture of that Tor themselves, by the way. They put it on their own websites. It has depicting you as a very old school PC. You're connecting to a whole bunch of other nodes. And these nodes in the network are connected to ultimately those websites you're trying to visit to. So what happens then is that when your computer is running Tor software, the Tor software figures out, okay, who else in the world is running Tor software? Because it's going to use those other computers to route your traffic up, left, right, down, kind of like in the movies or the TV, where you see the world and the map and the traffic is bouncing back and forth, back and forth. That's the kind of spirit of Tor. So what happens is your computer here, it wants to send a request to a website that's maybe over there, it's on the dark web, and it decides, for instance, to route it through not one, not two, not three, but more computers. That the Tor software will actually do is encrypt that request at least 3 separate times. So whatever web request I'm sending, whatever email I'm sending, whatever chat message I'm sending, whatever I'm doing, whatever I'm going from point A to point B is going to be encrypted with this node's public key, and that node's public key, and then this node's public key. And then, so this is the onion in Tor, the onion router. What I'm doing is encrypting layer upon layer upon layer, that mathematically, as per, if you read up about PKIs and public key, it's then only this node can peel off one layer, only that node can peel off another layer, only this node can peel off that layer using their own respective private keys, which then undoes the effect of having your encrypted traffic. So what you're really doing then is by perhaps choosing a different path, every request, everywhere you're going to is effectively covering your tracks in some sense. And so by design, the Tor software, it doesn't really remember much information about you. It doesn't have the sort of logs that I propose can be worrisome, at least in the context of web servers. And by design, Tor is it's going to preserve your privacy with a high probability. Okay, so by design, it just doesn't leak nearly as much information would. Now, this is to say, that if you're doing this for malicious purposes, trying to evade the authorities, hint, hint, that's not to say that that computer, this computer, that computer here couldn't be subpoenaed, so to speak, by some entity, some government. They could reconstruct theoretically the path your data took at some, at a lot of expense, a lot of effort, but it could be possible. The point is that it's generally quite a lot of work to do that. By this time, all that data has probably disappeared from those interior nodes, and they probably don't have that much information to actually share in the first place. And so increasingly, does it give you with higher probability and privacy by layering and layering and layering like an onion with encryption, and sort of trusting that these interior nodes of the node network are going to relay it to the final endpoint. So something to consider of interest. But realize too that just because of the way that the internet works with IP addresses, just the way that it works with port numbers, and it's still possible that on a network to know who is using Tor, for example. I could know if I was your sysadmin with some definitive proof. Okay, this person thinks they're using the onion router. I can tell it to them because I know some signature patterns. So if you're the only person at home, then obviously it's you. You're the only person on that network with certain parameters, certain headers, like I use a Mozilla Firefox, I use a phone, I use an Android device. So if you're the only person that uniquely identifies you within that network, because you're the only person that's using Tor at that moment, then that kind of game's up, so to speak. But at least the data itself is being there's a Wireshark would be a good example of this too. It can go through, that's a application layer wire sniffer. So it would be packet sniffer. So it would know at least high level information about where you're going. And so realize too in particular that all this is doing is just raising the bar to detection. So it's just raising the bar to privacy being invaded, because it does that, but it does not, as per the technologies we discussed, it doesn't give you absolute perfection to the same properties you would do. All right. I'm probably going to go on too long if I keep going on this, but point being that there are helpful tools, helpful mapping we can talk about how we can secure our stuff, but by using all the various technologies, all the things that together we've looked at, the stories we tell, the principles that we've now introduced, my hope is that in the weeks, the days, the months to come, you can try to find all those principles, the ideas, the building blocks to extrapolate how the technologies actually work and how threats might affect you, what questions you should be asking of either the software you use or the software you develop to make sure that not only your communications are secure, but also that it has those privacy preserving properties that you and your users and your customers might want. That was my introduction to cybersecurity. I hope you liked it. Thank you very much for staying behind. I've gone way over time. Please take care.
Marco, that was a great lesson. And I love the slides. I really loved the presentation. It was really good.
I do love my gifts. Who doesn't? Thank you very much, Chantal. That means an awful lot. Thank you very much. Sorry for spinning over. There's an awful lot still to go, and I will come back now and then when I can. I will leave you with that thought. If you want to go and check that website with the cool lessons, hacksplaining, it's a really cool one to go and to look at. There's tons of stuff on YouTube you can look at relating to these ones, but get stuck in. My hope is that we become better citizens online. So thank you for your attention. I'll catch up with you. Yeah, absolutely, Mohammed. So that's this one right there. I'll be available if you need me for anything. I'm in the background lurking. Good night, everyone. Have a fantastic weekend and stay warm. Take it easy.